Right, so lines are going to be one of the stars of calculus. So there are a couple of different equations of lines. I think, again, if you haven't taken math in a while, or if you just didn't work with lines last time you took math, it's really easy to kind of confuse things with m, the slope, with like y equals mx plus b, like slope-intercept form of a line. Right, so kind of key things, right? Once we have an x, once we have a variable, it's going to represent some type of like function or graph of a shape, whereas m represents just some number. It's a constant. It's unknown, but it never changes throughout a problem, hence the name constant. All right, so when I look at slope-intercept form, there are two constants. The constants are m and b. So the m is the slope of the line. The b represents the y coordinate of the y-intercept. Right, so a lot of times you say it's the y-intercept. It's a point. It's a part of a point, rather. So in this bottom one, the slope is going to be 6. The y coordinate of the y-intercept, I'm going to be lazy and do the thing I just said not to do, is 28. So we know that 0, 28 is a point that lives on our line. We also have point slope form. You may have seen this in a little bit of different ways. I'm going to write almost everything in terms of functions, right? There's going to be some use for like y equals stuff, but a lot of what I want to do is kind of recognize the functional notation that we can give different quantities. All right, so in this particular question, f of x, so let me actually be a little precise. X sub 0, f of x 0, that's going to be our point. So this x with a little underscore of 0, that's going to represent just some x coordinate that we know on the graph. This is the value that we get from plugging it in, aka it's a y value. Right, so our two constants are those. So our m still represents the slope. That hasn't changed. And the only difference now is that those other 2 points here represent a known point on the line. Right, so that f of x represents an unknown y coordinate. This x value represents an unknown x coordinate that's associated with that y value. All right, so if I just look at what I have, I've kind of matched things up. Well, the easy thing is the slope, right? The slope is what's in front of the parentheses with x. So our slope is going to be 6, and so our point that we know on the line is going to be equal to, well, what am I taking away from x? Right, so I have x plus 4. Plus 4 means that I'm subtracting -4, right? We could write this as x minus -4 if we wanted to. So the x coordinate of my point is -4. The y coordinate, right? So be careful. We're subtracting something away. So what am I subtracting away from f of x? I'm subtracting 4 away from f of x. So our y coordinate is going to be equal to 4. Right, so slope-intercept form has some use in my calculus classes. Point slope form gets more love from me, but the equation that gets the most love from me is probably one that you're unfamiliar with, which is called Taylor's form of a line. So Taylor's form of a line is really just taking point slope form and adding f of x 0 over to both sides. There's a reason that this form I think is useful. We use it much often, and we use kind of offshoots of this, like Taylor's form of a quadratic, Taylor's form of a cubic, the further we get, especially if you take a second level calculus course. So in here, like nothing changes, right? So we take everything that I had from slope-intercept form, point slope form, and we can just drop it in here. So these two equations are the exact same, right? I just added 4 over to the right side, so nothing changes. Our slope is still this value that's in front of the parentheses with x. That 4 now is just the y coordinate. Again, this is going to be kind of something that we can kind of see as a pretty easy function form, kind of using function transformations. There's one more form, like standard form of line, ax plus by equals c. There's really not a lot of use for that in calculus. I mean, system of equations, kind of writing things out. But if you forget the standard form is a thing for lines, you're fine. So here, this is just kind of like a derivation of where point slope form comes from. I don't really think it's that important, right? But if you're bored, right? So we know that x sub 0, f of x sub 0 is a point on the line, right? So we could say that our slope is equal to, well, normally it's the change in y over the change in x. All right, so I could say it's f of x minus f of x 0, right? That's a change in my y coordinates. And I could divide this by x minus x sub 0, right? If you're more comfortable with y2 minus y1, x2 minus x1, same thing. So then now, since this is an equation, we can multiply both sides by whatever we want. So now these values cancel out, and we're left with just this numerator. And this is point slope form. If I wanted to, I could, again, add that f of x sub 0 over to the other side. And now I have Taylor form of a line. All right, so these two forms are going to be important for us in calculus, simply because we usually don't care about the y-intercept. We care about some random arbitrary point that's somewhere besides, very close to the y-axis, right? So Taylor's form is going to be the one that I use most often. Point slope form also gets, is good enough for me.